Hey guys, this is for class for January, what am I saying? Monday, March 22nd, and also Tuesday, March 23rd. So there's 4 sections for tonight, you guys. It's a lot of work. So let's get started. I'm gonna make this as short and painless as possible. All right, so the first thing we're gonna do is figure out how to reduce fractions to lowest terms. So you have done that many times in your life. So we just gotta remind you of how to do that. All right, so the first thing I'm going to do is look at these two numbers, 15 over 105. So I know that they're both divisible by 5 because they both end in a 5. So I'm wondering if 105 is divisible by 15. So I put it in my little calculator, and it is. So whatever you divide by the top, you divide the bottom by the same number, and I get 1 over 7. Now you could put this in your calculator, 15 over 105. Hit the enter button and it simplifies it for you. So you know what? Let's just do that. Let's do the easiest thing possible. So when I put in my calculator 3 over 36, I get negative 1/12. 12 over 108 is 1/9. My calculator is doing this for me. Negative 12 divided by 4 is negative 3. Any number divided by itself is 1. All right, now I can divide 18 and 69 both by 3, I know. Can I divide them both by 9? No, I cannot. So I'm going to divide 18 by 3, and I get 6. And the B doesn't cancel because there's no B on the bottom. And 69 divided by 3 is 23A. So my variables didn't cancel or go away or reduce. So that's part of my final answer. All right, 29 is not divisible by 2. Y and X don't cancel, so this is simplified. If I divide 29 by 2, I get 13.5, or no, I get 14.5. But anyway, that's not a fraction, so we're going to leave it in this form. All right, so let's write this all out. So if I had 2 times y times y times y times y divided by 22 divided by 1, 2, 3, 4, 5 y's. Well, 2 divided by 2 is 1. 22 divided by 2 is 11. And then look what happens. Y divided by y is 1. Y divided by y is 1, y divided by y divided by y. So what do I have left? I have a y left in the denominator. So the only thing in my numerator is 1. And on the denominator, I have 11 times y, which is 11y. So that's my final answer. All right, so I know, once again, I can put these right in my calculator. We're going to do it the easiest way possible. I know these are both divisible by 5, so I get 3 over 4. These are both divisible by 7, so I get 5 over 3. 8 goes into 72 9 times, so I'm dividing the top and the bottom both by 8. 12 divided by 4 is 3, and any number divided by itself is 1. So we're going pretty quickly, right? All right, so right here, I don't know why these are written so small, but let's make them a little bigger. So I'm going to divide 4 and 44 by 4. So 4 divided by 4 is 1. 44 divided by 4 is 11. And then A divided by A is 1. And B divided by B is 1. So all I have left on the top is a 1. And then on the bottom, all I have is an 11. That's my final answer. So 36 and 45 are both divisible by 9. So 36 divided by 9 is 4. 45 divided by 9 is 5. And x divided by x is 1. So my answer is 4/5. And then here we have 4 times y over 76. And I have 4 y's. So I can divide 4 and 76 both by 4. 4 divided by 4 is 1. 76 divided by 4 is 19. And then I'm going to cancel when I have a pair on the top and bottom, I can cancel them because they're both just 1. So what do I have left? In the numerator, I have a 1. In the denominator, I have 19 times y is y squared. So there is my final answer. All right, now here we can see, well, what would I do with 11 to get to 77? I would multiply it by 7. So I'm going to multiply the top by 7 also, and my question mark is going to be 10 times 7 is 70. All right, what would I multiply 6 by to get to 42y? Well, I would multiply by 7, 7y. So I'm going to multiply the top by 7y. So 5 times 7y is 35y. Whatever you do to one of them, you must do to the other. What would I multiply 3 by to get to 18? It would be 6. And to get 3 to 18x squared, I'd have to multiply it by 6x squared. So I'm going to multiply the top by 6x squared. So 2 times 6 is 12x squared. So that's my question mark. All right, here we have what times 6 is 54. So that would be 6 times 9. So on the top, I'm going to multiply 1 times 9. I get 9. What times 11 is 66b? That would be 6b. So 6b times 5 is 30b. And then what times 10 is 50? That would be 5. So 3 times 5 is 15. So that's it. All right, so we're moving on. So that was 1R2, easy peasy. All right, now for 1R1, we're finding least common multiples. So you can read the screen. All right, now we do need to talk about some exponents. We were just working with a little bit of exponents, but a couple of rules you definitely need to know is anything to the first power is itself. So 6 to the first power basically means 6 one time, which is 6. 193 one time is 193. And then the rule for the exponent of 0, anything to the 0 power, it actually equals 1. So 2 to the 0 power is equal to, I don't know what this means. This is a typo. 2 to the 0 power is 1. 5 to the 0 power is 1. 46 to the 0 power is 1. The only thing that's undefined is if you have 0 to the 0 power. But you can even put it in your calculator. You can put 100 to the 0 power is equal to 1. So that is just a rule that you're going to have to memorize, and we're going to use in this section. Okay. All right, so don't forget with exponents, it's basically the base. So the big number is the base, and the exponent means, you can also call it a power. So 6 to the second power, or 6 squared, means 6 multiplied together 2 times. So 6 squared, or 6 to the second power, is 36. 10 multiplied by itself, 1, 2, 3, 4 times, is 10,000. Because when you have a 10 to a power, the power basically tells you how many zeros you're going to end up with. We're going to have 1, 2, 3, 4 zeros in the answer. 1, 2, 3, 4. So our final answer is 10,000. Of course, you guys have your calculator, and you can always plug these numbers right into your calculator. All right, so how would I rewrite 7 times 7 with exponents? I would say 7 squared, or 7 to the second power. 3 times 3 is the same thing as 3 squared. 2 times 2 times 2 is the same thing as 2 to the third power, or 2 cubed. And then 10 times 10 times 10 times 10, rewritten, would be 10 to the fourth power, which is 10,000. All right, so what is 6 times 6 times 6? Well, I'm just going to use my calculator. If you have this calculator, you're looking for the caret button, which is right there, right there. The caret button looks like this, okay? So if you have my kind of calculator, you would hit 6, you would hit your caret button, and then you would hit a 3. So 6 to the third power is 216. This one I'm going to do 5 squared. You have a squared button. You have an x to the second power button on your calculator. It's underneath the caret button, x squared. So you're just going to hit 5x squared, and that's 25, 5 times 5. And then 2 to the 6th power, 2 caret 6, 64. So one of the common errors is someone would look at this quickly and say the answer is 12. Well, it's not 12. This is not 2 times 6. It's not. This is not 5 times 2 and get 10. These are not right. So don't make that common error when you're using exponents. You have that number multiplied by itself, however many times the exponent tells you. All right, so we've already talked about perfect squares, and hopefully you guys kind of know those in your head, or you could write them down. But basically, I know that we don't want to use an exponent of 1. And in other words, they want us to rewrite this with a base and an exponent without saying this is 49 to the first power. That's cheating. So basically, this is 7 squared, right? So what exponent could we use to get 8? Well, that's 2 to the third power. I asked you guys to memorize the first 5 perfect cubes and the first, 15, 16 perfect squares. 169 would be 13 squared. I feel pretty confident it is. And 125 is our 5th perfect cube, would be 5 to the third power. So if you have those perfect squares and perfect cubes memorized, this will be easy for you. Evaluate each exponential expression. So any number to the first power is itself. Any number to the power of 0 is 1. 15 to the power of 0 is 1. And 10 to the first power is 10. All right, so now we want to go over the divisibility rules. Now, of course, you guys have calculators. So I don't want to spend a ton of time on this, but any number that ends in an even number is divisible by 2. So, of course, our even numbers are 0, 2, 4, 6, 8. They end in any of those numbers, they're divisible by 2. 3, I use a lot. Those are quick to do in your head. Basically, you take all 3 numbers and you add them up. So 3 plus 1 is 4, 4 plus 5 is 9. If the sum of the numbers is divisible by 3, that means the whole number is divisible by 3. That is exactly the same rule for the number 9. If the sum of the numbers is divisible by 9, that means the whole number is divisible by 9. Anything divisible by 9 is also divisible by 3, and vice versa. Well, it's not true. I was about to say vice versa is true, but it's not true for the number 6. 6 is not divisible by 9, but everything else it should be, maybe. I have to think about that one. All right, so basically you take the digits, you add them together. If that number is divisible by 3, the whole number is, so on and so forth. 4 is not as common as 2 and 3 and 5, but basically the rule says if the last 2 digits are divisible by 4, that means the whole number is. Okay, now 5 is an easier one. Any number that ends in 5 or 0 is divisible by 5. If any number is divisible by 2 and 3, that means it's divisible by 6. And then, of course, if any number ends in a 0, it's divisible by 10. So these are great rules to be aware of. Of course, we have calculators, but instead of guess and test, if you know these rules, it's going to help you figure out if a number, especially 2 and 3 and 5, 2, 3, and 5, I use those all the time. I can figure out in a matter of seconds if a number is divisible by 2, 3, and 5. So you should have those in your head, especially, okay? Add the numbers up real quick. Can I divide this whole number by 3? Well, let's add them up and see. All right, so basically, if you have a number that can be divided by another number, you would say that it's divisible by, this is just a little bit of vocabulary, so we're going to move on past that. All right, now a prime number is a number greater than 1 that has exactly 2 different factors, one in itself, like the number 7. 7 is prime, 11 is prime, 13 is prime. So these are the numbers that only have 2 factors, which is one in itself, right? If you have numbers that have more than 2 factors, that means it's a composite number. And then it gives you this little extra information, little trivia question. 1 is the only number that's neither prime nor composite. 1 is neither prime nor composite. Every other number is either prime or composite, but not 1. It's neither. All right, so we're going to say if this is P or C, is this prime or composite? Well, 2 only has 2 factors, 1 in itself. 7 has 2 factors, 1 in itself. 11 has 2 factors, 1 in itself. Now 12 I can divide by 2, by 3, by 4, by 1, and by 12. So that's composite. 29, if I add 9 plus 2, I get 11. So that means it's prime, only 2 factors. And 33, now I can divide 33 by 3, right? So that means this is composite. It has more than 2 factors. 605 ends with a 5, so that's a composite number. And 1 plus 3 is 4. 4 is not divisible by 3. I think 3 is prime. I think it is. I mean, I could guess and test, but I'm pretty sure. I know it's not divisible by 2 or 4 or 5 or 6, or the only one I'm not sure of is 7. 7 is very complicated. It's just easier to use your calculator, figure out something that's divisible by 7 or 11. But anyway, we're going to go with prime. If you find out it's wrong, you let me know. All right, 199. So I could add 9 plus 9 is 18 plus 1 is 19. So I know it's not divisible by 3 or 9. It's not divisible by 2. If 99 is not divisible by 4, we're going to call it prime. I think it is. I think it's prime. Do you think 199 divisible by 7? Or is it divisible by 11? No, we're going to go with prime. You let me know if I'm wrong. All right, now when we do the prime factorizations, we've already done a little bit of this, but let me just remind you. So when you're doing the prime factorization, you want all the factors to be prime numbers. So I'm always going to start with the smallest number I can think of. So I know this number is divisible by 2. So 2 times 45. And when I get a prime number, I'm going to circle it. So 45 is divisible by 3. So it'd be what, 3 and 15? Yep, so 3 is prime. And 15 is 5 and 3. So the prime factorization is 2 times 3 times 3 times 5, right? So just a reminder on finding the prime factorization. So you guys try these two. Pause the video and try these two and come back and check your answer. All right, so 60 is going to be 2 and 30. 30 is going to be 2 and 15. And then 15 is going to be 3 and 5. So we're going to do 2 times 2 times 3 times 5. And then 308, 8's an even number, so I can half 308. And I get 154. 154 is also even, so I'm going to divide that by 2. Oh, shoot. Oh, I hate when I do that. Did I mess it up totally? No. All right, so 154 divided by 2 is 77. I know 77 is 7 and 11. So that's 2 squared, whoops, 2 squared, 2 times 2 times 7 times 11. And that's it. All right, all the factors of 154. I'm going to skip that for now. All right, so now this is really the heart of this section, 1R1. We're going to find the prime factorization in order to figure out what the least common multiple of 2 or more whole numbers, including numbers that have variables. All right, so to find the least common multiple, now factors are small numbers, but these are multiples. Multiples are large numbers. So what we're going to do, and this is great practice, so we'll start with these two. We're going to divide this. We're going to start with the prime factorization. So we're going to divide 20 by the smallest number we can think of, which is 2. And then 10 would be 2 and 5. So 20 is equal to 2 times 2 times 5. 45 is divisible by 3. And then 15 is divisible by 3 and 5. So 45 is equal to 3 times 3 times 5. Now, to find the least common multiple, what you do is your answer must include every unique factor, and you want the biggest group of factors. So every unique factor, and you want the biggest group of factors. For example, 2 is a unique factor, and the biggest group is that there's 2 of them, right? So I have to use both of these 2's. So I use both of those. They're not gone. Now 3 is a unique factor, and I need the biggest group of 3. So there's 2 of them. So I'm going to use both of them, and now I've used those. Now 5 is a unique factor. Both numbers have a 5. The biggest group, each of them only have 1 5. So I'm going to use 1 5. And that, since that's the biggest group, it represents all 5s. So I'm not going to use 5 twice. I'm going to use just the biggest group of 5s. The biggest group is 1. I'm going to write down 1 5. It represents all of the 5s. So now on my calculator, I'm going to multiply 2 times 2 times 3 times 3 times 5. And my answer is 180. So 180 is the least common multiple of 20 and 45. All right, let's try another one, see what we get. Now this time we have 3 numbers. So we're going to break down 12 into its prime factorization. So we're going to do 2 times 6 and then 2 times 3. So 12 is equal to 2 times 2 times 3. 18 is equal to 2 times 9 and then 3 times 3. So 18 is equal to 2 times 3 times 3. 48 is equal to 2 and 24, and then 2 and 12, and then 2 and 6, and then 2 and 3, right? So we have 1, 2, 3, 4 2s. So 48 is 2 times 2 times 2 times 2 times 3. All right, so what we're going to do, we're going to find each unique factor, and we want the greatest group of that number. So I see 2's on all 3 columns. Well, my largest group of 2's is 4 2's. So I'm going to write 2 to the 4th, or I could write them out, it doesn't matter. But that represents all the 2's that I see. Okay. My other unique factor is 3, but I want the largest group of 3's. Well, I see 1 here, 1 here. Here's 2 3. I have to use the biggest group of 3's. So I could write times 3 squared or 3 times 3. It represents all the 3's. So in my calculator, I'm going to multiply 2 together 4 times, or I could use my exponent button. It doesn't matter. And then times 3, and I get 144. So 144 is the least common multiple of all 3 of these numbers. All right. Hope that makes sense. All right, let's try. You guys pause the video, try this one and see how you do. All right, so 36 is going to be 2 times what? 18, I think. And then 2 times 9, and then 3 times 3. So we have 36 is equal to 2 times 2 times 3 times 3. 24 would be 2 times 12, 2 times 6, 2 times 3. Didn't we just do this? Almost, not quite. All right, so we have 1, 2, 3. 1, 2, 3 times 3. And then 48, we did on the last screen, which would be 1, 2, 3, 4 twos. 48 would be 4 twos, 1, 2, 3, 4 times 3. Right? Yes. All right, so to get our least common multiple, we're going to find the biggest group of each unique factor. So once again, our biggest group of twos, 4 of them, represents all twos. And then our biggest group of threes are those 2 threes times 3 squared. So our greatest common factor is 2 to the 4th times 3 squared, and we get, oh, same answer. How is that? 3648. Oh, well, that wasn't a great example. I wish we got a different answer, but anyway. All right, so this is really the kind I was looking for right here, where we have some variables as well. So let's do 30. We have 30 is 2 times 15, and 15 is 3 times 5, right? So 30x squared is equal to 2 times 3 times 5 times x times x. 60 is going to be 2 times 30, and we know that 30 is 2 times 3 times 5. So 60xy is 2 times 2 times 3 times 5 times x times y, right? And then 50 is 5 times 10. Oh, actually, I could use a 2. 2 times 25, and 25 is 5 times 5. So 50y is 2 times 5 times 5 times y. All right, what are we going to use? Each unique factor and the greatest group of them. So I see 2's all over the place, but this is our largest group of 2's. So I'm going to say 2 squared. So it represents all the 2's. All right, I see 3 here and 3 here. My greatest group of 3's is 1. And then there's 5, there's 5, there's 2 5's right there. So my largest group of 5's is 2, and it represents all 5's. I see x's here and here. My largest group of x's is x squared. It represents all x's. And then I see a y here and a y here. I have to use a y. The largest group I see is 1, and it represents all y's. So let's simplify this. So we have 2 squared times 3 times 5 squared equals 300, and then 300 times x squared times y. And that is my final answer. That's the smallest number that all 3 of these terms up here would go into. Hopefully that makes sense to you. All right, you guys try this one and then come back and check your answer. So 8 is 2 and 4. So 8y squared is 2 times 2 times 2 times y times y. And then 12 is going to be 2 times 6. And 6 is 2 and 3. So we have 12yz is equal to 2 times 2 times 3 times y times z. And then 6 is just 2 times 3. So 6z is 2 times 3 times z. All right, so we see a 2. There's the largest group is 3 2's. So it represents all 2's. Then another unique factor is a 3. The biggest group is 1. I see a y. Here I have a group of 2. So our largest group of y's is 2, and then it represents all y's. And then I have the unique factor of a z. There's only 1. That's my largest group. So in my calculator, I'm going to multiply 2 to the 3rd power times 3, which is 24. So I have 24y squared times z. And that is my final answer. That's the least common multiple of those three numbers. All right, I think this is the last example, maybe? Nope, we have a couple more. All right, you guys try them. Come back, check your answer. All right, so 12 is 2 times 6, and 6 is 2 times 3. So 12x squared is 2 squared times 3. 28 would be 2 times what? 14, and 14 is 2 times 7. So, oh, I forgot my x's up here. All right, so 28xy is 2 squared times 7 times x times y, and then 21y only has 2 factors, which is 3 and 7 times y. So my largest group of 2's is 2 2's, 2 squared. That represents all 2's. I see a group, my largest group of 3's is 1. My largest group of 7's is 1, 7. I have 2 x's, represents all x's, and I have a y. So 2 squared, well, let's just put it in the calculator. So 2 squared times 3 times 7 is 84. 84x squared y. Alrighty. And then we have these three. We have 30 would be 2 times 15, and 15 is 3 and 5. 18 would be 2 and 9, and 9 is 3 and 3, and then 15 is 3 times 5. So 30y squared is 2 times 3 times 5 times y times y. 18 is 2 times 3 times 3 times y times z. And 15z is 3 times 5 times z. So we have a 2. We have 2 3's that represents all 3's. We have a 5, represents all 5's. We have 2 y's, and we have a z. So we have 2 times 3 squared is 9, times 5 is 90. So we have 90 y squared z. That's the answer. All right, moving on. Suppose it takes 3 weather satellites, A, B, and C, different lengths of time to orbit the Earth. Satellite A takes 24 hours. B takes, oh, it just says hours. It doesn't say how many. B takes hours, and C takes 12 hours. If they are directly above each other now, as shown in part A, of the given figure, in how many hours will they again be directly above each other in the position shown in part A? Well, I'm missing, oh, here it is right here, 6 hours. I don't know why my 6 is gone. All right, so we have 24, 6, and 12. So to answer this question, we're going to have to find the least common multiple. We want to know what's the smallest number they all go into. Well, of course, the answer is 24. I can tell that because 24 goes into 24 once, 6 goes into 24 4 times, and 12 goes into 24 twice, which means A will go around 1 time, B will go around 4 times, and the last one would go around twice. So we could break these down, or when it's easy like this one's easy to figure out because 6 and 12 will both go into 24. So the answer is 24. How many orbits will they each have? This one would have 4. This one would have 2, right? All right, I think we're ready to move on. Now we're ready for fractions. All right, so how would we get from 4 to 28? We multiply by 7, so 3 times 7 is 21. 5 times what is 55? 11. So 3 times 11 is 33. And what times 10 is 30 times 3? So 9 times 3 is 27. We've already done examples like that. Yeah, now we're ready for some fractions. All right, so if you have to find 2/5 of 7/3, the first thing you need to know is that the word of in math means to always multiply. So when you multiply and divide, you do not have to have common denominators. So those are the easiest ones to do. All you do is multiply straight across. So 2 times 7 is 14, and 3 times 5 is 15. So the answer is 14 over 15. Find 5 halves of 3. And of course I can make 3 over 1. Then I'm going to multiply straight across. 5 times 3 is 15, and 2 times 1 is 2, and then that's simplified. I could turn it into a decimal, but I don't need to. And your calculator not only multiplies fractions, but they simplify them as well. All right, so on this one, I multiply straight across, I get 48 over 35. This one I'm going to turn into this 3, I'm going to turn into 3 over 1. So 4 times 3 is 12, and 13 times 3 is 13. 13 times 1. Anything times 0 is 0. And then the last one, I can't quite see. Well, I'm going to move on anyway. All right, so I think the only ones you guys need help with is maybe if you have variables. So first thing you want to do is see if you can simplify up and down or across. So you can always simplify across. So do you see how this has an x on the bottom and an x on the top? We're going to get rid of those. X divided by x is 1. I'm going to divide 20 and 32 both by 4. Yep. So 20 divided by 4 is 5. 32 divided by 4 is 8. Now I'm ready to multiply straight across. So 7 times 5 is 35. 8 times 9 is 72. And then I have a y left in the denominator, so don't forget that one. All right, I'm going to simplify up and down, so my a's cancel. 6 is divisible by 2, and 16 is divisible by 2. So now I'm going to multiply straight across. Negative 9 times 3 is negative 27. And then my b is over there. And then 8 times 7 is 56. And I think they're both divisible by 3. No, they're not. Just kidding. All right, and then the last one, can I cancel anything? Well, I can divide 5 and 10 by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. That's the only thing that cancels. So now multiplying straight across. 5x times 7 is 35x. 4 times 3 is 12, times 2 is 24, and y times y is y squared. So there we go. All right, if you go on a road trip of 180 miles in the mountains and 11/18 of the trip is downhill, how many miles of the trip are not downhill? Well, the first thing we want to think of is they turned this whole trip into 18/18. 18/18 is equal to one whole trip. And they said 11/18 is downhill. So to figure out how many are not downhill, we're going to subtract 11/18 from 18/18. If 11/18 is downhill, that means that 7/18 is not downhill. Does that make sense? So we want to figure out what is 7/18 of 180, right? This is our math problem right here. So I'm going to divide 18 by 18 and get 1. 180 by 18 is 10. The bottom is just 1, so I'm going to multiply 7 times 10 and I get 70 miles of my trip is not downhill. All right. In a class of 95 students, that's my whole class, 38 received an A. What fraction of the class did not receive an A? Well, if 38 first thing I'm going to do is subtract 38 from 95. And I get 95 minus 38 is 57. So that means, oh, crap. Previous. Next. If 38 got A, that means 57 out of the total did not receive an A. All right. So read it carefully, you guys. Read it carefully. All right, now when we divide fractions, and we've done this before, we're going to keep it, change it, flip it. Y'all remember that? KCF, almost like Kentucky Fried Chicken, but KCF. So we're going to keep it. We're going to change division to multiplication, and we're going to flip it. 25y over 2. And then can we simplify up and down? Well, we can divide 25 and 40 both by 5. So I get 5. My y's cancel. And 40 divided by 5 is 8. So now I multiply straight across. Negative 9 times 5 is negative 45. And 8 times 2 is 16. And there we go. All right, we're going to keep it, change it, flip it. So negative 10b over 7 times 6b over 11. So nothing cancels. Nope. So I get negative 60b times b is b squared over 77. And that's my answer. All right, and the last section finally is 2R2, where we are going to add and subtract fractions. They must have common denominators. So when they do have common denominators, all you got to do is add those numerators together. These are both divisible by 5, so I'm going to divide them both by 5, and I get 2/3. Your calculator will do that for you, of course. And then 5 plus 3 plus 1 is 9/11. Easy peasy, right? Put it in your calculator. All right, these, we have to have common denominators. So our least common multiple of 8 and 12 is 24. But of course, you guys can put them in your calculators. So 8 times 3 is 24. So 3 times 3 is 9. 12 times 2 is 24. So 7 times 2 is 14. And we get 13 over 24. Our least common denominator here is 20. So we're going to do 20 plus 20 plus 20. So 4 times 5 is 20. So 5 times 1 is 5. 10 times 2 is 20. So 3 times 2 is 6. And 5 times 4 is 20. So 2 times 4 is 8. So now we're going to add 8 and 6 is 14 plus 5 is 19/20. Or put in your calculator and you'll get the right answer. Now, it can be a little tricky when we start using variables, but it doesn't have to be. Now, obviously, all of these already have an x in the denominator. So we're going to use 30x plus 30x plus 30x. So what times 10x is 30x? Times 3 times 3. 6 times 5 is 30x, so we're going to do 20, and then times 3 again, and we get 9. So our denominator is 30x, and our numerator is 41 plus 9 is 50, and then of course these are both divisible by 10, so we get 5 over 3x. All right, now we can start using those prime factorizations to figure out what these are. But I'm telling you, when it doesn't have a variable, stick it in your calculator. So I'm going to let you guys do those in your calculator. All right, so what about the next one? It says Jenna's income is $4,600 a month, and she plans to budget 4/7 of her income for rent, 1/10 of her income from water. What fraction of her income does she plan to spend each month on these two items together? What fraction? So basically, we're adding together 4/7 plus 1/10. So we're going to stick that right in our calculators. And we're going to do 4/7 plus, whoops, that's not right. 4/7 plus 1/10 equals 47 70th. So over half, right? Half of 70 would be 35. 35/70 would be half, so more than half. And then it says, what amount of money does she intend to spend each month on these two items together? So basically, if this is her total, we want to know what is 47/70 of 4,600. So we're going to take our answer in our calculator and we're going to put times 4,600. And the answer is, it says round to the nearest dollar. So according to my calculator, rounded to the nearest dollar, she's going to spend about $3,089 on these two things. All right. Is that it? Oh my goodness. I thought there was even more than that. All right, you guys, that was a lot of slides, but I don't know how we are with time. I forgot what time we started. So anyway, so that's Monday and Tuesday's lesson. So unfortunately, y'all have 4 sections of homework to do, but hopefully it won't be too hard on you. All right. All right, you guys, I will see you at 6 or later, depending on when you feel like you need to come to class, and bring your questions if you have any, and I will see you guys later.